NASA can't explain it. An object from deep space, 3I/ATLAS, is acting like it wants to stay. Instead of flying past the sun as expected, new Harvard data shows it may be using gravity itself to slow down and remain trapped in our solar system. If that's true, it changes everything we know about interstellar visitors. Is this nature or design? Let's dive right in. From the very beginning, 3I/ATLAS defied expectations. Every interstellar visitor before it, like Oumuamua or Borisov, came from random directions, moved fast and left without looking back. They followed the cold, predictable laws of celestial mechanics. But 3I/ATLAS arrived differently. It's racing toward our sun at 124,000 miles per hour, yet its trajectory is almost perfectly aligned with the flat plane of our solar system, the same invisible path all our planets share. That shouldn't happen by chance. Statistically, the odds are lower than 1 in a billion. To some, it's just coincidence, but for others, it's the first sign that this visitor might not be random at all. And the more scientists looked, the stranger it became. According to Harvard astrophysicist Avi Loeb, new data suggests something extraordinary. 3I/ATLAS may be slowing down, almost as if it's deliberately resisting the sun's pull. That shouldn't be possible for a natural object. Yet the numbers keep pointing toward an unsettling possibility, that it might be using the sun's gravity itself to perform what's called a gravitational braking maneuver. If true, it means this object isn't just reacting to physics, it's using physics. That single idea changed everything. Loeb explained that such a maneuver would rely on the Oberth effect, a known principle in rocket science, where a spacecraft gains maximum efficiency by firing its engines at the lowest point of its orbit. It's how we send probes across the solar system with minimal fuel. But for an interstellar object to perform this on its own, it would need energy, precision, and timing we've never seen from nature. The most dramatic moment came on October 29th, when 3I/ATLAS reached perihelion, its closest point to the sun. At that moment, it was moving at over 155,000 miles per hour, and the sun's light made it completely invisible to every telescope on Earth. If anything unusual happened then, a small burst of thrust, a sudden trajectory shift, we wouldn't have seen it. And maybe that's exactly why it happened then. For weeks, 3I/ATLAS was hidden behind the sun. Then Loeb's team revealed something even harder to explain. Based on its brightness, spin, and gravitational influence, the object doesn't behave like a solid body. In fact, the data implies it could be hollow. That one word, hollow, ignited global debate. When the object passed close to Mars earlier in October, spacecraft orbiting the red planet barely registered its gravity. For something several miles wide, weighing potentially billions of tons, that's impossible. It's like seeing a mountain move but casting no shadow. The math left scientists with only two options. Either it's made of an unknown ultra-light material, or it's mostly empty space inside. And that's where logic turns to awe. Nature doesn't make hollow shells this large. Engineers do. Loeb's analysis goes further. If the object truly has a hollow structure, it's not just a physical anomaly, it's a message of intent. A hollow design implies a purpose, a vessel, possibly even cargo. That's when Loeb introduced what he calls the dandelion seed hypothesis. It's an elegant, chilling analogy. Just as a dandelion scatters hundreds of lightweight seeds across the wind to expand its reach, a civilization could scatter small autonomous probes across the galaxy, each one self-sufficient, each one capable of exploration or observation. And if 3I/ATLAS is such a vessel, perihelion, the moment when the sun hides it from our view, would be the perfect opportunity to release them. No one would see it. No one could stop it. That idea might sound far-fetched, but it's not baseless fantasy. It's grounded in data, and more importantly, it's testable. When 3I/ATLAS reemerges from behind the sun, astronomers will look for clues. If it's a natural comet, it should break apart randomly, scattering debris in different directions. But if it's engineered, the fragments will move with purpose, each following a specific course, as if guided. That's the real experiment Loeb has set up, a global test of truth. But just as his team prepared for this moment, something strange happened. After 3I/ATLAS passed near Mars, the data stream went silent. NASA, the European Space Agency, and even China's Tianwen-1 orbiter, all of them had a clear view. Yet, within 48 hours, NASA announced a government shutdown, freezing public communication. ESA claimed technical delays. China stayed silent. Weeks passed. Nothing. Only a few low-resolution images were released, and they showed almost nothing. A faint haze, a blur. Then official statements insisting it was noise. To many, that felt less like coincidence and more like containment. Because if this was just an ordinary comet, why the coordinated silence? Why hide the most significant interstellar observation in history? Even among skeptics, something didn't add up. The object's reflectivity, for instance, isn't typical of icy comets. It's metallic. And its chemical signature, drawn from spectral analysis, suggests compounds similar to planetary crusts, not deep space ice. That means it might have originated from the surface of a world, not the frozen edge of interstellar space. Piece by piece, the story starts to form something uncomfortably coherent, a hollow metallic object, a perfect alignment with our solar plane, a slowdown near the sun, a blackout during its closest pass. Individually, these facts could be coincidences. Together, they tell a different story. Now, Loeb's Galileo project is tracking both space and Earth's skies, looking for any unexplained activity that could coincide with 3I/ATLAS's trajectory. If strange aerial phenomena or sensor anomalies appear in the coming weeks and they align with this event, it won't be speculation anymore. It'll be correlation, the kind science cannot ignore. And yet, there's still humility in Loeb's tone. He isn't saying it is alien. He's saying, let's find out. Because the truth, however unsettling, is better than the comfort of denial. Even seasoned astronomers quietly admit we might be witnessing something historic, a moment when the boundaries of science, imagination, and reality begin to blur. If 3I/ATLAS really has anchored itself to the sun's gravity, then for the first time in human history, an object from another star system may have decided to stay. That thought alone is enough to make us question everything we know about the universe and our place within it. And perhaps the most haunting part isn't that it's here, but that it might be watching. 3I/ATLAS reminds us that the universe still holds secrets powerful enough to humble even our best science. Whether it's a strange comet or a deliberate visitor, one truth remains. We're witnessing history unfold in real time. At Galactic Breaking News, our mission is to bring you the facts, the theories, and the truth behind the unknown, clearly, responsibly, and without hype. If you found this story valuable, hit like, leave your thoughts in the comments, and subscribe to Galactic Breaking News with the notification bell on, so you don't miss the moment we uncover what 3I/ATLAS really is. Stay informed, stay curious. This is Galactic Breaking News, and the universe is just getting started. Just discovered in Virgo, Comet C/2025V1 Borisov has appeared right beside 3I/ATLAS. and both are shining unusually bright without any tails. Astronomers are stunned, two active comets breaking every known rule of comet physics at once. Is this a visual illusion, a cosmic alignment, or something entirely new forming between them? The mystery is deepening fast. Let's dive right in. When astronomers spotted C/2025 V1 Borisov for the first time, it wasn't the discovery itself that sent shockwaves through the global astronomy community. It was where it appeared. The object drifted into view right between Earth and 3I/ATLAS, the same mysterious interstellar comet that has already been rewriting physics textbooks. And this time what we see defies explanation again. Two comets, both strangely bright, dense, and completely tailless. A combination that, by all conventional understanding, simply shouldn't exist. It began quietly at the Margot Observatory in Crimea. A local astronomer, Gennady Borisov, was reviewing routine sky scans when he noticed a faint blur sliding across Virgo, moving too fast to be a distant galaxy, too slow for an asteroid. He knew that name, Borisov, carried history. 6 years ago, this same man had spotted two I/Borisov, the first confirmed interstellar comet. This time, his telescope had captured something just as strange, but closer, brighter, and eerily silent. Within hours, global observatories joined in. From Japan to Spain, telescopes locked onto the same faint glowing orb. The data lined up. A coma nearly half a minute wide, no visible tail, and a brightness increase of 5 magnitudes in under 5 days. That's a 100-fold jump in visible light, something comets only do after violent outbursts or fragmentation events. But this one remained calm. No debris, no gas jet, just glowing. Experts compared notes, trying to fit it into known cometary behavior. But the models kept breaking. Why was a newly discovered comet so bright yet refusing to grow a tail? Was it made of heavier, carbon-rich dust that sunlight couldn't push away? Or was there something masking its emissions, perhaps an unusual electromagnetic effect? By November 6th, the situation took another strange turn. Sky charts revealed C/2025 V1 Borisov and 3I/ATLAS appearing side by side in the constellation Virgo, like twin embers burning in the same region of the sky. Social media exploded. Amateur astronomers across the world posted photos showing two glowing orbs, both eerily round, both tail-free. At first glance, it looked like a cosmic alignment, as if these two objects were somehow connected. But when astronomers ran the orbital data through JPL and ESA software, the truth was more complicated. They weren't close at all. In fact, they were separated by tens of millions of kilometers. What we were witnessing was a projection illusion, a trick of perspective caused by our viewing angle from Earth. Still, the odds of two anomalous, tailless comets appearing in the same part of the sky at the same time, astronomers admitted privately. That's statistically near impossible. So what are we looking at? Coincidence? Or are both